Hey guys, welcome back from the weekend. I hope it was a great weekend for you. Today's lesson is going to be on lesson 122, and we're going to call this day one because we're going to spend a few days on this particular lesson. And we're going to start off today looking at something called asymptotes. All right, so that weird word that we see here in the notes is called asymptotes. That's how it's pronounced. Our content goals for today is to introduce and graph a rational function. So this will be a new type of function that you probably have not seen before. So we're going to start with the basics. We're going to look at a rational function. We're going to create a table for it, and then we're going to graph the points from that table so that we can see its shape. All right, we're going to look for and identify an asymptote. Since rational functions tend to create asymptotes, we'll be able to look for that on the graph and identify it. And then our last content goal is to be able to write the equation for the asymptote that we see in the graph. All right, so today, like I said, we're going to introduce a new function called the rational function, and it typically has this form where we see something being divided by x. It is essentially any function where the variable x is in the bottom of a fraction. All right, so let's look at one of these rational functions using our calculator, and we're going to create a graph for it so we can see its unique shape. So the function that we're going to be investigating today is this one right here, f of x equals 1 over x plus 1. So remember I said a rational function has the x, or the variable, in the bottom of a fraction. So this one is a rational function, even though it's not just an x, it's an x plus 1. There's many different variations of rational functions. Okay, so I'm going to go to my calculator and turn it on here, and if you haven't done so already, make sure you hit the y equals button to get to this screen, and we're going to enter our function in just as we see it here. If you need to pause the video so that you can get it typed in before we go on to the next part, go right ahead. My one note for this is when you put this in, you need to make sure that you put a parenthesis around the bottom of the fraction, around the x plus 1 in the bottom of the fraction. Here in the notes, I did not put that in because most textbooks, most places are not going to write the parentheses in, but when you put it into your calculator, it is important that you put that parenthesis around the bottom. Otherwise, the calculator will mess this thing up. All right? So here we go. So first thing I'm going to do is I'm going to go to my table before I even look at the graph. All right, so I'm going to go to my table, and notice that we want our table to go from -6 to +4. And so I've already scrolled up and got my calculator to show me all of the values going from -6 to +4, and I'm going to grab these values here for the y values from my table. So -6 has a value of 0.2, and that'll be a -0.2. And then we have -0.25, and then we have -0.33, and then we have -0.5, then -1, and you'll notice at -1, this is kind of weird here. It says error. We've seen errors before, so maybe not as big a surprise, but there's an error there. That's an important error. We're going to come back to that later. All right, so at 0, we're at 1. At 1, we're at 0.5, and then at 2, 0.33. So we start to see some values perhaps repeating here, but in a positive way, right? So these were negative and these are positive, so that'll be kind of fun to see that on the graph, right? So we got 0.25 and then 0.2. All right, so let's get these plotted. Let's see what this thing looks like. I'm going to come down here now that I got my table, and I'm going to work on plotting these points right here. I'm going to go ahead and hit graph on my calculator so I can get an idea of what this is supposed to look like. And wow, that is a weird looking graph, but don't worry about it. We're going to get this thing plotted, no problem, because we've got points up here. All we've got to do is plot the points, and we should be able to shape the graph. So let's see what happens. So we'll start with our first point here at -6, -0.2. So I'm just going to count to the left 6, 1, 2, 3, 4, 5, 6, and then go down 0.2, and I'm going to eyeball it. Okay, so it doesn't have to be perfect. Right? When we do the decimal values, just try and eyeball it. The next one's going to be at -5, so I'm going to count left 5 and down 0.25. So almost at the same exact vertical placement, but just a little bit lower, right? And then at -4, we'll be at -0.33, so maybe just a little bit lower. Not too much. Again, I'm just eyeballing these. Doesn't have to be super exact. Right, and then at -3, so 1, 2, 3, we're going to go down to -0.5, so about halfway in between. And then at -2, we'll get to -1. Right, and you start to see, right? You start to see this thing. It's creating that curve shape that we see over here, right? We're getting this part of the curve. All right, so we start to see this thing shaping a little bit as we plot those points. All right, now at -1, there's an error. Okay, and we're going to talk about that in just a second. So I'm going to skip ahead to this next one, 0, 1. Okay, so I'm going to get that point right here. There's 0, 1. That is this point right here on our graph. And then we're going to go to 1 and 0.5. So I'm going to go right 1, up 0.5. And then 2 and 0.33. And then we're going to go to 3 and 0.25. And then the last one here at 4 and 0.2. So you kind of see what we're doing here. We're shaping this other curve, right? Because if you look at the graph, there's two of these curves here. So we've got that one kind of shaped with the points that we have, and we have this one shaped with the points that we have here. And then I'm going to go ahead and draw my two curves. And you'll notice when I draw these, right, so as I go off to the left here, it never actually gets to the x-axis here. So I'm going to make sure that when I draw this, I'm going to draw my curve, and I'll draw it in a different color. I'll draw it blue just like it is on the calculator. And I'm going to draw that curve so that it never touches the x-axis. Or I'm going to do my best to, because I have this weird digital pen that's really hard to draw with. And it kind of goes like that. There we go. It's not too bad. All right, I'm going to put arrows on the end because it does go in both of those directions forever and ever. And then I'm going to get this one. Now you'll notice what this one does is it kind of bends up. It never gets to the -1 value here. So I'm going to draw this one. Same thing, never touch the x-axis. I'm going to try and get as close to it as I can, but never actually touch it. And then we're going to come up here. We're never going to get to -1, but we'll get real close to it. And then, oh, darn it, I messed that one up. Try it again. As I said, I really suck with this digital pen, but there it is. All right, so we kind of have the shape with some points helping me to shape that, and my two curves. Okay. All right, now let's start describing the graph, right? X-intercepts. So remember what I said before, when we graph this thing, it actually gets really close to the x-axis but never touches it, so that would tell us that there are no x-intercepts on this graph, so we just say none. And if that happens in MyOpenMath, sometimes they'll have you type none, or sometimes they'll have you type DNE for does not exist. All right, y-intercept, where does this thing cross the y-axis? Well, it hits the y-axis right here. We can see that one plain as day. And we can see here where x equals 0, it's at 1. So we have a y-intercept at 0, 1. All right, a minimum, which is the lowest point on the graph. Well, here's part of my graph, and it goes down, and I put that arrow on there because I know it goes down forever. So we would say for a minimum, it is either none or DNE. All right, a minimum does not exist for this graph. And then we go to the max, right? Well, a max is the highest point. Well, I'm looking at my graph over here, and notice that this thing goes on forever and ever on its way up, right? So there is no max. So we would say none, and then DNE. All right, now these two things are new, right? We've never used these to describe a graph before. So this is kind of a new thing, the horizontal asymptote and the vertical asymptote. And you might remember when I said, hey, we got real close to the x-axis, but we never quite touched it. And then there was also this -1 value that we got really close to, but didn't touch. And my graph, like I said, is pretty bad because I have the digital pen, but we should not have actually crossed over that -1 value. Okay, these values that we get really, really close to on our graph, those are the asymptotes. We get really close to these values, but we never pass them. Okay, so I'm going to switch colors here. I'm gonna get a real thick. Let's go with a real thick green pen here, and I'm going to draw in the asymptotes so that you can see them. So we have an asymptote here on the x-axis because we get really close to the x-axis, and we never touch the x-axis. Okay, so since this line is horizontal, we would call that a horizontal asymptote. There is a vertical asymptote, remember, at -1 right here. And again, I drew it horribly, and you can see I can't even dash a line with this stupid pen. Okay, so, and you see how horribly I drew my shape. I should have never crossed over this green vertical line that I'm drawing here at -1. That is my vertical asymptote. Okay, so again, I'm going to turn on my graph just because the calculator makes a much better graph than I do by hand. You'll see here they don't draw in the asymptotes, but you can see that the function never crosses over -1 vertically, and it never crosses over the x-axis horizontally. It looks like it does because it gets infinitely close as you go off to the left and to the right, but it never actually touches the x-axis. So that's how I know where those asymptotes are. Another way to identify the vertical asymptote is to look at your table. I'm going to go up here and look for the error. Right? Wherever you see that error, that's where that asymptote is going to occur vertically. All right? You can't really see the horizontal asymptote in the table, but you can see the vertical one for sure wherever that error is located. All right? So now we just got to figure out, well, how do I write down the horizontal asymptote? Do I just say horizontal asymptote at 0? Nope, we actually have to write an equation for the horizontal asymptote. And since it's horizontal, okay, for the horizontal asymptote, the horizontal asymptote hits the y-axis, right? So wherever the horizontal dashed line that I draw hits the y-axis, that is the number that I'm going to write down. So I'm going to say y equals 0. That's my horizontal asymptote. My vertical asymptote, which is right here, is going to hit the x-axis somewhere. And in this case, it hits it at -1. So I'm going to write this one with an x equals. So I'm going to say the vertical asymptote is located at x equals -1. Okay. All right, guys. So that's it for today. I just wanted to show you a quick example of graphing the rational function. They're not easy functions to graph, as you saw by my demonstration. But describing them is really no different, other than we're adding these two new features down here known as the asymptotes. Okay, so you just have to remember, an asymptote is that place on the graph that you just can't pass. You get really close to it, but you can't touch it. All right, that's how you know you're looking at an asymptote graphically. On the table, you'll see that error for the vertical one. All right, guys, that's enough for today. We're going to explore this more tomorrow. You might have noticed we didn't talk about domain and range. That's because I'm saving that for tomorrow, and we'll look a little bit deeper at these graphs. All right, guys, have a great day. Give the practice problems a try. Let me know if you have questions in the Zoom chat.